Thank you for 4 fantastic presentations. Now we have about 15 minutes or so for questions. I'd like to invite the panelists to come up and join us, and we'll get audience questions in here. And while they're doing that, I'd like to thank David Ackerley just for the invitation to learn here with you today. A lot of what I do is translate between the expert community and the broad public, and I've learned a lot here today that will help me doing that, and starting with next Thursday, U.S. Secretary of the Interior Sally Jewell will be at Climate One talking a lot about water. You're all invited. It's free in San Francisco at Climate One if you'd like to hear some more about water in the United States. I'd like to ask one overarching question that might tie all these 4 presentations together, then we'll get the audience questions and we'll get off to lunch. I was thinking about the volatility of precipitation and rainfall patterns and thought about water pricing in markets. In energy, we're going from flat pricing to dynamic pricing. Energy costs different prices different times of the day. Perhaps water pricing might be different depending on where we are in precipitation patterns. And that gets to questions of markets. For example, Todd Dawson, whether the redwoods might be part of the California offset markets, and creating markets around the scarcity that you've all outlined, whether it's rice or water pricing in India or those sorts of things. So we'd like to tackle the role of creating new markets in new ways around ecosystem services as a way to get at the solutions of the problems you've outlined. Who'd like to tackle that first?
So should the economists go first? You said price.
If you don't, it's going to look bad.
All right. Should we price a scarce resource? I mean, yes, right? So I think we're not even there yet, right? You drill a hole in your backyard, you pump as much as you want. You pay the fixed costs of drilling, and thereafter you pump as much there is. So there's that issue. Assigning property rights correctly in shared aquifers, because you're sharing water with your neighbors, is the first issue here. Second, there's also the issue that a lot of residential customers don't understand their water pricing and what they're paying. There's these increasing block rate prices, for example, so informing people of what they're paying. But if you're talking about real-time water pricing, what you're going to have to put in is real-time water meters throughout California in order to get at people's real-time consumption, which if the experience from the real-time meters and electricity is a lesson, not everybody's a big fan of that. But as the economist, the first thing I would like to see is proper assignment of property rights and pricing of the scarce resource. Then the real-time, to me, is secondary.
Yeah, a lot of places, Sacramento is just getting water meters for the first time. Todd?
Yeah, I'm not sure how to actually comment to that in terms of sort of natural water resources and how...
Or redwoods as part of offset markets, so that there's a way that they have a value that we recognize. If there's a price on it, we'll care about it and preserve it.
It's certainly being discussed in terms of the carbon offset market because the trees grow so rapidly and they are a source of carbon sequestration. So that's largely where that discussion has gone. The kind of alternative to that is because they inhabit such small zones, people say, well, even if they're sequestering a lot of carbon, in a global sense, they're not actually having a very big impact, although they may have an impact on California. But with respect to water, I don't think we've actually thought deeply about that issue.
Maybe it's a bad question. Sally, would you like to, water markets, are there market solutions to the things that you identified? Or other, what are, not market-based, what are the solutions?
Todd and I were talking about this earlier, and I'll defer to Max to tell me whether I'm talking sense or not. But it does seem that one of the things that enables us to be a productive and wealthy society is that we aren't spending 50% of our income on food, and we're not spending 25% of our income on water. So in some ways, these things that are extremely essential to us, we benefit tremendously economically from not paying perhaps their full cost. And yet, when we start to put that in the context of change and scarcity, I think that creates a distortion that maybe comes back to make this a very difficult problem. I don't know how to resolve that, but to me that seems to be the tension, that these are scarce but essential and not substitutable resources.
Paying the full cost hurts. We don't like that. Yeah, Dustin, I'm not sure. Yeah.
I'll just add, in Australia, where I've worked extensively, water markets have played a critical role in climate adaptation. The startling statistic during the recent drought was in 2006 a 70% reduction in water allocations, but only a 1 to 10% reduction in gross value in irrigated agricultural production. And that was in large part because of the flexibility allowed through water markets. Now, the corollary I would add is that markets have a cost, and that the reform process of assigning property rights has taken decades. The conservative estimate was on one of the slides I used, where federal expenditures on the cap and trade system totaled about $25 billion. So that transition to economic incentives is a long process.
Tim Flannery said a couple of years ago that what happens in Australia will happen to California. So Australia matters, because some people think that what happens there will happen here. Let's get your involvement here. We have a microphone. Yeah, so we are recording this. So who'd like, we'll have a chance for a couple of questions. There we go.
Just between Dustin and Sally, if there were regions where it made sense to recharge groundwater, then how would you make an economic model to make that, what was Chris's phrase, the sustainable, robust water system that we're looking for, resilient?
And in terms of opportunities for groundwater recharge, I mean, it really requires, building on Sally's point, to recognize the interaction between the two sources. And the best example, one of the most advanced examples I'm aware of, is in Arizona, where they've created water banks to recharge groundwater. And the big challenge there has been to recognize the spatial link between groundwater and surface water. In many cases, they've created groundwater recharge credits, but that's allowed for local groundwater depletion in areas, so it hasn't fully achieved that integration.
If I can not so much talk about the way to do an economic model, but one of the real challenges that we are going to face in doing what is otherwise a very conventional hydrologic study in India is a dearth of understanding, a dearth of data that is collected, that is often collected by somebody who has no incentive in getting that data right. So for instance, there's an awful lot of data that says that these irrigation tanks are still totally full, because why would I bother visiting the village to record the level in the tank that nobody's using anyway? I'll write down my favourite number of the day and go get an ice cream. So we couldn't even begin to think about a system, because right now we do not understand the interaction well enough. And again, this is, I mean, it's basic hydrology. We're not going to break any boundaries in the way of how hydrologic science works, but it's fundamental missing information for making intelligent decisions about a particular place.
One footnote on that, in California, there's a new fracking law in California, and I'm going to talk with Senator Pavley about that next week. And there's actually groundwater measurement provisions in the fracking law that she thinks will have get at some of the first-time measurement, because a lot of places it's illegal to measure groundwater in California. And one byproduct of the fracking law is there's going to be lots of data collected about for fracking purposes, but also on quantity and perhaps quality. So perhaps some more transparency on water in California. Next question. Sure. Oh. Okay.
Thank you very much. Max, your comments on the situation in India are pretty scary from a food security point of view. So I'd be interested in hearing what your colleagues in India how they're responding to that. I mean, are they aware, and if so, what are the solutions? Are they looking towards kind of breeding programs for different kinds of more resistant rice, kind of bringing back the brown cloud to lower the temperatures? I mean, what? And if they're not, then how does one motivate them to kind of start thinking about these things?
So that's been a very interesting experience. I ran into some of the same sort of scenarios that Sally ran into, where you state things and they sort of start nodding, but they can't. Many folks can't write it down in a journal. The important thing to remember is that both the brown cloud and greenhouse gases are bad for rice, right? So bringing back the brown cloud isn't going to help you. That's the first important part. Second, it comes down to ultimately two questions: is what are the sensitivities, right, of rice yields to these outcomes? And the numbers we're getting are very close to what sort of conventional wisdom is of my Indian colleagues, so there was a lot of match there. The thing you argue over is projections in climate. Rainfall projections are still hugely difficult to pin down, so we're just looking back. But going forward, where it's getting drier and where it's going to get wetter at what times of the year, that's really the key question for rice. If you take the non-marginal change, the warming itself, everybody's worried about what's going to happen to the snowpack. Because that, again, has an interesting linkage to not only temperatures, but these air pollutants too, because these particles lay down on the snowpack, it's dark, snow melts faster, so there's an accelerating sort of feedback mechanism there that is not going to be pleasant. But there's been an interesting sort of exchange of information and ideas between colleagues in India and here that's been very productive.
Yes.
I have a question to Max on California, agriculture, irrigation, et cetera. We said about 6 million acre feet south of the Delta to the San Joaquin Valley. It's a very rich agricultural production because it's a desert. High evaporation yields high yields. On the other hand, we really are producing a lot of alfalfa and low value crops. So I guess my question is, the solution of an economist is, how do we get the right mix of maybe higher value crops that use less water in a democratic way that helps us address the common good of California dealing with a scarce resource like water? I guess in other words, we're sending a lot of water down the drain that's ultimately evaporated into the atmosphere to produce alfalfa.
So the world expert on this from the econ side is in the other room talking right now, Dave Sunding, who's thought about this quite a bit. But as far as I'm aware, the biggest water user in California is ag alfalfa, right? So we're growing grass, which ultimately goes to feed. As an economist, we like to think of, if you take the full cost of a resource, social cost of a resource, what you want to put is you want to put it to its highest value use. So if you ask me, is my personal subjective estimate that the marginal gallon of water or acre foot of water's highest use is alfalfa? I don't know the numbers off the top of my head, but an educated guess, probably not, right? There's a big issue here, and the issue becomes very complicated, and it's again one of property rights in terms of water and how markets function here. But the issue of perennials, right? If you're thinking about that, we're producing now 95% of the world's almonds, for example, I think, or 90%, which take a lot of water. That's a 20-year investment, I think. So you put a tree in the ground, after 5 years you get some almonds and you hope for it to live for another 15. A couple of bad water years can have tremendous economic damage on some of these specialty crops that we grow here. So while I think we should maximize value of that water, we also have to think very much not only about the total amount of water we're shipping down, but variability in that water supply year to year, which lets users make educated decisions going forward as to what they're going to plant. Because one bad year or 2 bad years wreak havoc on almonds. Alfalfa, you know. All right.
So volatility changes that equation. Let's have probably our last question, 1 or 2 more. Yes. And then David.
Hi. So oftentimes when I hear about fresh water, I hear sort of the negative and sort of sad stories of how we're doomed. And I'm curious if there are opportunities in the future for hope and possibly new areas to move into that could really help alleviate some of the challenges that you guys are talking about.
Lift us up before lunch.
No, I don't want to hog the microphone here, but some of the most interesting work going on campus with colleagues from all over and that the Gates Foundation is interested in is, the safety of water supply in the developing country context. How do you get people not just water, but clean water, right? The negative health consequences of getting polluted water and kids drinking it, they have lifelong negative consequences on wages, ability to survive, number of days of school attended, and so on. So there's a lot of work that should still be done, but that makes me somewhat hopeful, is not just focusing on allocation of gallons of water, but what kind of water goes to what types of individuals. So if you want to read depressing yet hopeful literature, the sort of water, sanitation, and health literature that comes out of Sega on campus, for example, is really exciting. Plus, you know, the P that we never talk about, how many people are going to drink how much water and eat how many pounds of crops thereafter. That's another one that, again, Malcolm is going to talk about later.
We'll talk about that in this next session. Anyone else on that?
I think maybe part of the depression comes from the fact that we talk a lot about the agricultural sector, which, you know, perhaps there are fewer opportunities to be as technologically creative there as there are in the urban water sector. And I think if you were sitting in the other room right now, there would be more of the, wow, we've got cool technology, we're doing great things. That said, there's tremendous capacity for enormous water savings through improvements in agronomy, improvements in crop selection, simple, I mean, really silly things that happen in India in the sense that the electricity market and the electricity distribution system there is so erratic that you pump whenever you have power. So farmers are not in a position, they're not empowered to be able to make conservative decisions about water use because they're operating in an environment of scarcity with respect to electricity. These are not insoluble problems. These are very much solvable problems. Clearly, an important first step is to get to the point where decision makers are prepared to acknowledge the nature of the problem. And I should say that in talking about a place in Karnataka, all states have different characteristics, and this is not a state that is well known for having been particularly upfront and open about dealing with its problems. So there are better examples in India, and there are many examples worldwide of ways to do things better.
And just remember, LA has a pretty good water story, as much as in California, it pains me to say this. But Orange County in LA, you heard the mayor say this morning, that's urban is not the biggest part, but they have a pretty good conservation water story to tell in Los Angeles. I think we have to end it there. Time for lunch. Let's give another round for this fantastic.